Okay, the next problem we are solving is binary tree zigzag level order traversal. Okay, so what does it mean? Like basically, this is an extension of breadth first search algorithm. Okay, so what is breadth first search? Like I mean, this traversal, right? We can traverse the tree in a two order, right? Like I mean, it can be depth first search or a breadth first search, right? So breadth first search is meaning nothing but this in this way order, right? We traverse it like this. As the name suggests, it's a breadth. Okay, so this is how we are going to traverse. What are the element is there? We're going to read it 1, 2, 3, 4, 5, 6, 7. This one in the depth of search we'll be using the recursion. Okay. So now how are we going to solve this? What is this problem about, right? So let's say that we just discussed that it would be like this, right? Everything. But what they're asking is it should be a zigzag manner. Okay. So what is zigzag meaning? Zigzag meaning this one. Okay. So what should we doing here is the output should be like looking like one should be iteration should be like this, and the other level should be iteration should be like this. So the answer would be initially it should be like 1 2 3 4 5 6 7, right? So now it would look like 1 3 comma 2. Okay, and the next we'll go to in the positive direction, and finally we'll go in the negative direction. Okay, so this is what with the expected like I mean this is the problem about. Okay, now how let's see that how are we going to solve this. And as we're solving the like I mean we are iterating this way, right? It obviously indicates that we need to use the breadth first search here, right? So like we'll modify the breadth first search a bit to solve this problem. Okay, let's try to quickly revise how the breadth first search algorithm looks, right? So basically what we'll do is in the breadth first search, every time we visit a node, we push it to the queue. Okay, we push it to the queue, but wherever we pop out of the element, we will make sure to add the left and right element to the queue. Okay, so let's say that we have a queue like this, and we have added a, like whenever we visited a node, we have added a one, right? And later what we'll do is when we start, like I mean whenever we started iteration, right, like it will be having the element. So we'll start our iteration. Initially we'll define our queue as like this. Okay, we'll define like this. So now we will process it until this queue gets empty. Okay, let's say that there's an element in a queue, so we need to pop it. Okay, so we'll enter the loop. So what we'll do is we'll pop the element, but you need to make sure that whenever you pop, you need to make sure to insert the left and right nodes. Okay, if it exists. If not, we should not be inserting the none nodes for a leaf node, right? Or any blank one. So we should be just, what should be doing is like we should be inserting the left and right whenever we pop. So this is getting popped. Okay, so let's say that this is getting blocked. Okay, so now whenever we pop, we need to add the upcoming left and right nodes. Okay, similarly the same formula follows. Like this queue is not yet empty, so we'll have to eliminate this. When we are eliminating this, we need to make sure that we add a 4 and 5. I mean it is a left and right child, right? 4 and 5, we added it. So if you just see the pattern, we are just iterating through from the left to right. Like I mean, this is the done 1, 2, 3. So whenever the next comes, I will be iterating to the 3. Correct. So whenever I'm done with the 3, I'll have to insert the left and right child. It will be 6 and 7. Right. So this is the breadth-first search. That was a quick recap. So now let's see that okay, now what is happening here is we are traversing in a format of 1 2 3 4 5 6. Okay, so before actually going to zigzag, let's try to understand how we extract the level elements. Correct. So currently the output should look like something like this, right? 329, all these things. Okay, for time being, let's assume that 920 is itself is asked. Okay, no zigzag, nothing, just return me the nodes that are present for each level. Okay, now how are we going to divide it? How are we going to get an elements for a particular level? Okay, so basically what is that one thing we need to understand here is, so how we are going to do it is like whenever we check, right? So whenever we started checking, right, let's say that if there is an element in the queue, started reading and popping it, this the element, right? Whenever we check whatever the element that are present in the queue, like number of elements. Okay, number of elements, like that is for particular queue. Okay, so let's say that when we started, right, it was looking like something like this one. Queue was like this. Okay, so when we enter the loop, we check that if the queue exists or not. Okay, so for that particular level, like I mean for one iteration, we can consider it as one level. Whatever the element that are present, that will go in one level. Okay, so it means that whatever the, like I mean number of elements that are present in the queue, right, that represents a that particular level. Okay, so this will be one. So when we popped it, so new element got added. Correct. What were the new elements? New element were 2 comma 3. This is for next iteration. Correct. This is for next iteration. So when I come in the next iteration, what I will do is I will check the number of elements that are present in the queue. So this will give me an idea how many elements are present in the current level. So like how can I, how much level I, how many elements that I will have to pop to build this list. Okay, so basically we will be popping the element. Okay, it's like, I mean, it's all about how we are understanding how many elements that we need to pop for a per level. Let's say that we have so one key here is whenever we start that loop, right? How many, the number of elements that are present in the queue is nothing but the number of elements that are present in the queue. Okay, so currently when we are iterating this level 1, right, this is level 0, this is level 1. So there are two elements. It means that I can check the length of the queue, it is a 2. Okay, so that means there are two elements that I need to pop for this level to get to build my temporary array. Okay, so what's happening here is 2 comma 3. Okay, so we start a iteration, and also we need to make sure that whenever we pop, always we'll have to add that reference thing, correct? So I will pop this one. What I will do is 4 comma 5 I will add. Okay, and 6 also I will add, and 7 also I will add. By this time I would have popped 2 and 3. Okay, for this level I knew that when I started this iteration there were only two elements, so I will be popping only two elements, and remaining will be 4 5 6 7. After popping we inserted these values. Okay, so in the next iteration what will happen, again I will check the what is the number of elements that are present in the queue. It means 4, right? You can clearly visualize it here. The actual level number of elements that present in the level is actually 4. Okay, so we'll apply the same formula, like, I mean, we'll pop this, pop this, pop this, pop this. Okay, whenever we pop, we make sure to add the elements. So we must have added 8 9 10 11 13 14. Okay, we must have added that values, and we have eliminated all these values for that level. Okay, and whenever we eliminate, we need to make sure that we keep track of it, so that we just traversing it, right? So that we need it to an answer actually. So ultimately, so again you can check, right? We have these many elements in the queue. It indicates that the number of elements that is present in that current level. So now we can just pop it and build a list, and use it for a final result. Okay, then now let's quickly see the code approach. It will be more clear. Okay, if not wrote, we'll just returning it. We'll be building the you should have a basic understanding of the BFS, so that it will be more clear here. So we are building the queue here with the initial value of the root. Okay, and here what will happen, for each element we are building the sub arrays. Basically this is the sub arrays that we are building. Okay, so we will be checking how many elements that we are going to pop to build the current level. Okay, so n is equal to length of queue, we'll be popping it, and the number of elements present in this queue, based on that we'll start popping it. And once this is down, right, like, I mean, once we pop all the elements, so what we can simply do is, actually you can simply use the for loop also. That will be more clear actually. For underscore in the range, underscore meaning, like, I mean, we are not going to use that variable anyway. So for we can just simply use the for loop here instead of decrementing this again and again. Okay, so what we can do is, so pop all the element, make sure of building that whatever the values you pop. Okay, ultimately once you pop, just use it at the end. Okay, so this will, like, I mean, if you just at the ultimately what we'll get is 3 is one temp result, 9 comma 20 is one temp result, 15 comma 7 will be temp result. But what we need to do is we need to print it in the, like, I mean, send back the result in a zigzag format, correct? So what we'll do is we'll keep a track of the levels that we are traversing. Level is equal to 0. And like, I mean, if it's a even level, right, we'll be printing the result whatever it is, or else we'll be reversing it and adding it to the result. Okay, and ultimately you'll have to also have to make sure to update the levels. Yeah, that is it. Yeah. Just to summarize that, like, how are we going to print the big zigzag order? So zigzag meaning we are traversing it this way. It means that we are going to use the BFS algorithm here, and we'll be going to modify the BFS a little bit here. And what is the modification areas? We need to should keep track of how many elements that going to come in the current level. Okay, so how are we going to do it? Like, if you check the queue size, we will know that how many elements to pop. So we will pop those many elements, and we'll keep it in a temp result. Okay, so we'll be using that for the next processing. And we always need to make sure that whenever we pop an element, we need to insert the I mean insert its left and right side values if those are not none. Okay, yeah, that's it. Thanks.